Hi, welcome back. In our previous lesson, we started with the algebraic representation of substitution and income effect. Today, we'll be moving on to some practice questions. Let's consider a consumer named Ella who consumed good X and good Y. If the price of good X is £1 and the price of good Y is also £1, and then Ella has an income of £8 per day to spend on good X and good Y. We noticed from our previous lessons during our utility maximization that if we have a utility function as this, which is x raised to the power 0.5 and y raised to the power 0.5, and given our budget constraint, if we solve this utility maximization, we will arrive at a demand function for good x as this function and for good y as this. We have done this extensively in our previous lesson when we were looking at utility maximization. So we are just going to move on, given this information, to look at substitution and income effects when there's a price change. Our first question is, calculate the optimal demand for good X and Y and the optimal utility at the current prices and income. We know that this is the demand for good X and this is the demand for good Y. We know the price of good X as 1 and the price of good Y as 1. And we know income to be equal to 8. So given this information, the demand for good X is simply going to be the income, which is 8 divided by 2 multiplied by the price of X, which is 1. So this gives us 4. And then for Y, this is going to be income divided by 2 multiplied by the price, which is 1, and this gives us 4 units of good X and good Y. Now, if you're moving on to the utility, we have a utility function as raised to the power 0.5 and Y raised to the power 0.5. So given the quantity for X and Y, we have a utility function as 4 raised to the power 0.5 and 4 raised to the power 0.5. So this is going to give us a utility of 4 utils. Now our second question is, if the price of good X increases from 1 to 2, by how much will the demand for X change? So we know the demand for X as income divided by 2 multiplied by the price. So if we denote the new price as P prime, then we're simply going to say our new demand is income, which is 8, and then 2 multiplied by the new price of X, which is 2. So this gives us 2 units. Our third question is, under the new prices of good X, what level of income will allow the consumer to have his old level of utility? Illustrate this graphically. Now, let's first look at this graph before we move on to solving the question. We have this consumer named Ella, who was initially on budget constraint 1 and indifference curve U1 and consuming bundle E1. Now, because the price of good S increased from 1 to 2, Ella moved from budget constraint 1 to budget constraint B2, which moved Ella to a bundle E2 on indifference curve U2. The question here is, instead of Ella moving to U2, if we want to keep Ella on U1, even though the prices have changed, then it means that we have to compensate Ella with enough income to move her from budget constraint B2 to budget constraint BC. We know that the old utility is 4. This is Ella's utility before the change in price. So the aim of this question is to help us split the total effect into substitution and income effect. So the first step is to hold constant the income effect and isolate the substitution effect. To do this, we need to know how much income has to be adjusted to keep Ella on the same level of utility despite the change in price. Now we know a utility function to be U being equal to X 0.5, Y 0.5. And the price of good X before it changed was 1, and the new price Px prime is now 2. We can substitute our demand function as X is noted as income divided by 2 Px prime, where now prime is the new price of x raised to the power 0.5, and then y we can rewrite as income divided by 2py because the price of y has not changed. Even the price of good x has increased. If we want to keep Ella on 4 utils of utility, then we need to adjust the income. So it means that our income here is also going to be prime and prime, which is simply indicating that we need a new income to keep Ella on the old utility given the new price. So let's rewrite this. So we need to keep Ella on the old utility, which is 4, given that the price of good X has changed. If we put the price of X in this, then we have I divided by 2, the new price of good X as 2, then we have for Y the new income that we need and the price of Y as 1. So we simply have to solve for I prime here, which will give us the new income needed to keep Ella on this level of utility, even though the price of good X has changed to 2. We simply solve this as 4 equal to I prime 0.5 plus 0.5 divided by 4 raised to the power 0.5 to 0.5. This is going to give us I prime being equal to 4 times 2 times 2 raised to the power 0.5, which is equal to a new income of 11.3 pounds. Now, this means that the consumer will need an income of 11.3 pounds to be able to attain their original level of utility after the price change. If we come back to our graph here, we see that at budget constraint B1 and B2, income, which is original income, is 8. We've calculated that to keep Ella on the same level of utility, even though the price has changed, the level of income that will allow us to do this is income being equal to 11.3. So then the difference between these two incomes is C here. So if we want to calculate C, we have C being equal to 11.3 minus 8, which is equal to 2.3. Ella needs an additional income of 2.3 to keep her on the same level of utility, even though the prices have changed. So this is all that we have on the first part of our practice question on income and substitution effect. Our next lesson will be part 2. If you enjoyed today's lesson, consider subscribing. Thank you.